Good afternoon, good morning, whenever you're watching this video. I am not at school today. I was going to be at school today, but decided my daughter has a 100 degree temp and decided to take off tomorrow just to make sure she would feel better before going back. So, anyways, I hope that you have an awesome Friday. Because it's Friday, I'm going to give you guys possibly the easiest lesson we've done in a couple of days because of what we've done. This will be very, very simple. Okay. I think I told you guys, no, I know I told you. There are two types of logs. Okay. Common log, and we said that anytime we're talking about common log, just when you see the word log, it's understood if there's nothing there, this is understood to be base 10. And they did that because obviously in dealing with numbers, base 10 deals really easily with decimals. So because it was used so often, they decided to just go ahead and say, hey, common log is base 10. Well, there's another thing that has existed um, in math so often that they decided to give it its own variable, and that is this thing called E. And E is actually called Euler's number. Euler's number. And again, it's just a number that occurred so often that they decided to just say, hey, just like pi is always 3.14, this number happens so often, let's just give it a variable too. Let's call it E. And every time you're dealing with this, instead of having to write this number or think about this number, we can just call it E. It's almost just like pi. In fact, what we call it a mathematical constant. It just happens so often, it gets its own variable that we are always going to refer to it. And that value for E is 2.71828. Now that's rounded. It actually keeps on going. I want to show you real quickly in the calculator where you can find it. There's two places. One, if you want to raise it to a exponent, it's right here under a button that we're actually going to talk about here in just a minute. See it, e to the x? You could use that button if you're raising it to an exponent. But if I just want to see what the value is, see how you have pi here? It's just below pi, e. And that's not e like the letter, as you can see right here under sign. That's e for Euler's number. So if I went second divided by and pushed equals, sure enough, there is that mathematical constant that we refer to as E, or Euler's number, and it's 2.718281828. Now, listen, this looks like it continues. It does not. Okay, that it will not keep going 18281828. That's just a. In fact, if you want to look up, it is one of those things that just keep on going forever. It's an irrational number that never repeats. It never ends. Okay, Euler's number. So a couple things about it. These things occur as the base of exponential and logarithmic functions that describe real world scenarios. Real world scenarios. So therefore, just like it has its own variable, it's also going to be given its own logarithm. Okay? Exponential functions that have base e are called natural base exponential functions. For example, we have this one right here. It's p e to the rt. This is called continuously compounded. Continuously compounded. We're going to talk a little bit more about that next week. But that is a formula that you can use to calculate how your money might increase if it's compounded continuously. PE to the RT. But it uses that base. Look, here's my exponent. It uses that base of E. All right? So when we talk then about it being a natural base exponential function, we also have logarithmic functions that have an understood base, and they're base E, and they're called natural logarithms. And again, it happens so often. And just like when we had common log base 10, we are going to have natural log, which is understood base e. So we use to represent that ln, okay, ln, which I understand it's logarithm that's natural, okay? That's how I want you to think about it, logarithms that are natural. So, like I said a second ago, when you see that written, when you see ln, you know you're dealing with a natural log. You know that you're dealing with an understood base e. You don't have to write it, just like the base 10 that we talked about a second ago. We don't have to write base 10. We just write base e. So for example, when we have a problem like 1 through 3, where every one of these exponents have a base of e, if I'm going to write those in logarithmic form, because it's base e, we're going to use natural log, ln. And you still do the loop. I don't have to put e. I don't have to make base e the base of your logarithm. It is that naturally. Okay, so it's ln of 24 equals x. So the exact same way that we were doing the work last week, and that's what makes today's lesson so easy. See, look at number 2. It's exponential. It has a base e. So if I want to write that as a logarithm, I'm going to write it as a natural logarithm. Understood base e, and then we do the loop. So it's ln of x equals 9. And then the last one, again, I see that base e, so I know I'm going to use natural log, understood to be base e, of 72 equals x plus 5. And that's really all there is to it. So if we go the opposite direction and we have that ln of x, again, remember, it's understood to be base e. So when I write this as an exponent, it's e to the 58th power equals x. See, I did the same loop that I've done last week and we continue to do now. Look, number 5, natural log, ln of 6 equals x. If I want to rewrite that as an exponent, it's understood to be base e to the x power equals 6. See, nothing new. This is all stuff that we've already done, and therefore it should be pretty simple. Again, you see this natural log. You understand it's base e to the 32nd power equals x minus 9. And that's how you rewrite natural log or natural exponents, natural base exponents to logarithms, use ln, or natural logarithms to natural base exponents. Very, very easy. Okay? Now, when it comes to solving equations, same as what we've done in the past. You've got 2 options for logarithms. See, these are definitely log on both sides. See the ln here and the ln here? So when there's log on both sides, you drop off the logs and you solve. So it's 4x minus 27 equals 15 minus 2x. To solve this, I'm going to add the 2x. So 6x minus 27 equals 15. I'm going to add 27. So 6x will equal 15 plus 27 is 42. And then I'm going to divide by 6. So x equals 7. Easy, right? Now, the next one, number 8, a little different. Look, I don't have ln on this other side. So therefore, I'm going to solve this one by rewriting it as a what? As an exponent. I hope you remember that because it's the same thing. Here's the only deal. What's the base of my logarithm? Well, it's a natural logarithm. So the understood base is e. And then you do the loop. E to the 2nd power equals 8x. So I go to my calculator, and since I'm doing e to the 2nd power, I'm going to go ahead and use second ln. Now look, if I didn't want to use that, that's fine, but that's what I get. I could also have done second divided by and then raised it to the 2nd power. It doesn't matter. You're going to get the same answer. So e to the 2nd power is going to give me 7.39 equals 8x. And then I'm going to take that 7.39 and I'm going to divide it by 8. And my answer is Whoops, I went before I saw it. 0.92, it looks like, 0.92. So those are your logarithms that you solved identically to when we were solving these. Only difference is what we were doing previously, it said log. Now it says ln. So that tells me that my understood base is e. Now if we go the opposite direction, this one, remember, identify your variable in your exponent and its base. We've got to get that alone. So I'm first going to add 6. That's 8. And now that is alone. So we're ready to rewrite this as a logarithm. Now again, look, I can't make 8 have a base of e, obviously. So I'm going to rewrite these all the time as a logarithm. So since my base is e, I'm going to use natural log understood base e of 8 equals y plus 3. So I'm going to go to my calculator, and I'm literally going to use the ln button. That's what I do when it's natural log. Okay, I only use it when I'm doing natural log. You don't need the natural log with a different base like we had with logarithms and did alpha window 5. You don't need that. We're only going to use ln if it's base e. You understand that? We're only going to use it if it's base e. So here I get 2.08 equals y plus 3. So the last thing I'm going to do is I'm going to subtract that 3, so you get negative 0.92. And that's it. Now, the last one has one little trick to it. I want you to recognize what the exponent is, and that was wrong, and its base. Its base is the e. Its base is not 2e. You've got to get, see, 2 is not being raised to the x power, just e. So that's what we've got to isolate. So the first thing I'm going to move is I'm going to definitely move the 7 by subtracting it. So that leaves me with negative 2 times e to the x equals negative 2. Again, if I want to solve this correctly, I don't solve it as far as writing as a logarithm from here. I still got to isolate that base and its exponent. So I'm going to divide by negative 2. So e to the x will equal positive 1. Now we can rewrite it as a logarithm. So here's my mindset, here's my thinking. Because it's base e, I'm going to use natural log, understood base e, of 1 equals x. So I'm going to go back to my calculator. The natural log of 1 equals 0. So x equals 0. And that's really all there is to it. This is easy because of what we've done to get us here. Like I said, we're only using this because we're dealing specifically with this new thing that we call E, or Euler's number. It's an automatic value, a mathematical constant, 2.71828. Okay? It just happens so often in real world situations that they decided, like pi, to give it its own value, and therefore, because it always occurs with exponential or logarithmic equations, instead of trying to make it fit into common log, or even changing the base of your log to 2.71828 every time, they decided to make it its own button, and that is ln, or natural log. So, easy lesson. I think you'll be able to do the homework way before school is out. It's 12 problems, but the first 6 are just simply rewriting them in logarithmic or exponential form, and then you've got the 6 problems here to solve. So, easy. You're going to have a good weekend. Hopefully, you'll have this done before you start. Thank you, Mr. Bingham, for being the sub today. Hope you have a great weekend. See you on Monday.